Hey everyone, welcome to CodeTav management. So we have discussed the principles for the solid. Single responsibility principle, open closed principle, list of substitutions principle, and interface segregation principle that we have covered. So last one is DIP, which is dependency inversion principle. So basically, the dependency inversion principle states that the high level module should not depend upon the low level modules. So they should depend on the abstractions. Okay. So abstractions should not also depend upon the details, and details should depend upon the abstractions. Okay. So in this way, instead of high level of modules depending on low level modules, both will depend on the abstractions only. Okay. So this is the main fundamental part of this dependency inversion principle, right? So no dependency should target a concrete class, right? So this is the main concept. So I will say you like what is the inversion principle is. So suppose a bookstore uh, is there, and they supposed tell us to build a new feature that enables the customers to put their favorite books. Okay. So in order to implement the new functionality, we create a lower level book class and a higher level self class, right? As the bookstore told us to build a new feature that enables the customers to put their favorite books on a shelf, right? So for that case, uh, we create a lower level book class and also the higher level self class. So the book class will allow the users to see the reviews and read a sample of each book they store on their shelves. Okay. So the self class will let them add a book to their shelf and customize the shelf. Okay. So like I'm showing you here, suppose public class book is there, and there the users can see the reviews, right? So void see review, this is the method, right? And also they can read the sample. Okay. So void read. Cool. So now we will make the another class which is self. So public class self, right? So keep the class name as with the capital letter. Okay. Then we will make the object of the book, and then void add book, right? And then also we can customize the book, right? So void customize book. Yeah. So everything looks fine, but as the high level self class depends on the low level book class. So the code violates the dependency inversion principle, and this becomes clear when the store asks us to enable the customers to add the DVDs to their shelves. Okay. So in order to fulfill the demand, we create the new DVD class. So for that, public class DVD, and there they also can see the reviews, and they can watch the sample. Okay. So for that reason, I am just copying these two parts, and instead of read, just I'm making the watch the sample, right? So now we should modify the self class too. uh, for that reason, like it can accept the DVDs also. Okay. So however, this would clearly break the open close principle. As in the open close principle, it was mentioned that it is open for extension but closed for modification, right? So we will now modify the code through which this dependency inversion principle will follow, right? So this basically violates, this is the violations of this DIP. Then we will do the modification of it, right? So the solution is to create an abstraction layer for the lower level classes, like lower level classes in the sense your book is one lower level class and DVD is another lower level class and self is the upper level, means high level class, right? So we will just create the abstraction layer for these lower level classes, and we will do so by introducing the product interface. So both classes will implement it, like I'm showing you. So I will make one interface. So this is the interface product, right? And inside that, this suppose void C review, this method is there, and this is abstract method. Okay. So also void get sample. So right, this interface we have created, and then we will just implement this interface for the lower level classes, means for the book and DVD classes. Okay. So now public class book implements product. Okay. So then what it will do, it will just override the public void C review. Okay. And inside that the logic should be there, and also I will override this sample. Suppose here this is get sample is there, right? So get sample. So then your logic should be inside there. So in the same way, we'll implement the product interface for the DVD class as well. Okay. So instead of book here, we will write the DVD. Okay. So now this self can reference the product interface instead of its implementations, like for book or DVD. So the refactored code also allows us to later introduce new product types. Like if the bookstore will tell you like any other thing to uh, review, see the review or get some sample for that in the specific shelves, then you can easily modify that code, right? So now what you will do? So now this is public class product, sorry, self, which is the higher level class here. So now it will take the reference from the product. Okay, product interface. So now void add product, right? And inside that, yeah. And then also like here you can see it was taking the references from the book itself. So now it is taking the reference from the product interface, right? So now void customize self, right? And inside that your logic will be there. So in this code, it follows the Liskov substitution principle, as the product type can be substituted with the both its subtypes like books and DVDs without breaking the program. So it also follow the Liskov substitution principle. So we are not giving any other things in the in a class. So each class will have the single responsibility as well. So this single responsibility principle or SRP, it also following the open close principle. As now if you will require some other class to implement it, okay, then you can easily add that one. So it will be good for extension, but you will not need to modify the existing code. So it also following the open close principle as well. And next, it's also following the Liskov substitution principle as well. And interface segregation here, like one interface is there. So you cannot tell that in this part. But yeah, so all the principles it is following, and also the dependency inversion principle is also following. So we have implemented the dependency inversion principle as here the high level class means this self class. It's not dependent on the lower level classes like book or DVD. Okay, it only taking the reference from the product interface. Okay, so this is also following the dependency in the inversion principle as well, right? So yeah, this is the concept here. So if you want, then I will make another video for this means another examples for this dependency inversion principles if it's not clear to you. But yeah, along in that, I will describe some other examples or questions you can say. So like you have heard about the dependency injections in the Spring framework, right? So one question may come up in your mind, like how is this dependency inversion principle is related to the dependency injection of the Spring framework? Okay. So DIP relation with dependency injection in Spring, right? So yeah, so it would be correct if you think that dependency inversion principle is related to the dependency injection as it applies to the Spring framework. So uh, this dependency inversion mainly uh, introduced by one scientist, like you can say computer scientist, or like Uncle Bob Martin was there. Okay, so Uncle Bob Martin introduced this concept dependency inversion before Martin Fowler, I think, who introduced the term dependency injection. So dependency inversion introduced before the dependency injection. Okay, so these both concepts are extremely related. So dependency inversion is more concerned on the structure of your code, and moreover its focus is keeping your code like loosely coupled. On the other hand, the dependency injection is about how the code uh, functionally works. Okay, so main difference is in that way, like code refactor, clean coding. For that part, this dependency inversion principle is mainly there, but dependency injection is mainly related to its functionality. Okay, and along with that, you can also say like dependency inversion principle has been very well implemented in the Spring framework. So the beauty of the design principle is that any class which is injected by the dependency uh, inversion framework is easy to test with the mock object and easier to maintain because object creation code is centralized in the framework, and client code is not messed up with that. So yeah, this is the thing. So next is like benefits. We have discussed the benefits of the other principles as well. So here also we will discuss the benefits of this dependency inversion principle. So the if you want to know the benefits, so those are basically it keeps your code the loosely coupled. Then it also easier to maintenance. Then better code reusability is also there. Okay. And if you want to know about the disadvantages, so the disadvantages are like when we use the principle, so it results in an increased effort. Okay. So we need to maintain. So basically, when we use this principle, it results in an increased effort. So we need to maintain more classes and interfaces in a few words, like more complex code, but more flexibilities. So if someone applies this principle, then it will be beneficial for the future maintenance. So these things are there. So if you have any other questions, you can comment down below. Thank you.